Hi friends, now we will see summary on binomial distribution. This is again nothing but just wanted to conclude this topic. So as the important library that we will import is pandas and numpy, then what we will do is we will do one descriptive, or we can say a small analysis on this particular tennis.csv. Here we are reading the top 5 row, and here you can see this is the data set looks like. We have the column that is tourney id is here, and this is regarding the tennis, right? So all the information regarding that will be here. Now drop the records where the winner hands or loser hand column has u in them, right? So what we'll do is to drop this column where the value is u in those both topic. First we will access for winner hand. Yeah, we are accessing it and we are checking it if it is u, right? So drop function is here, so it will drop that, right, from that particular index. And where axis will be, again it will draw the complete row, right, and which will drop in our writable format, means it will actually permanently drop that row. Similarly for the loser hand where it is u, again drop that. And if we check that we have DFF, we are taking the data set value from winner hand to loser hand, right? So here we will get the other value rather than u, because u value already have been deleted. So let's take what it is telling, that create a data frame containing records where the opponents had different dominant hands, right? So here what we'll do is, first in the A we will get winner hand where it is right handed, and B loser hand if it is L handed. What it is telling, for a boolean array to find the instances that tells if the winners were right, and for B if the winner were left-handed. Okay, so now C is comparing if A equals to B. Okay, here what it will do is there is a boolean array which tells if opponent have different dominant hand, right? So in the D we will get DFF of C, right? So if we print that D, here you can see that it will give us the D. Success failure rate are also there. Now to get that different, or we can say different dominant hand, so what we will do is we will make a success column, and here we will tell that okay, if a winner hand we need to replace that. If it is R, then say it's success, and if it is left-handed, say it is failure, because as L is for loser hand, right? So here if we get the head, you can see that the success column is also here. Now it is telling that create a crosstab between the winner hand and loser hand column. So to get that crosstab, what we'll do is, again we are reading that data frame, right? And for right-handed we are telling that just some winner hand if it is right, and some loser hand if it is right-handed. Similarly do that for left-handed, some if winner hand is left-handed, and some if loser hand is left-handed. Again the index will be now our winners and losers. So here in the cross tab we will see that for winners there are right-handed 774 and left-handed are 133. Similarly for loser, right-handed are 784 and for left-handed it is 122. If we sum that cross tab and get the sum, so the total that for right-handed and left-handed will be this one. Now it is telling that calculate a probability of winning given the players is right-handed, right? So now again to get that probability, what we'll do is we will get the probability winner given that it is right-handed, right? So what will be the probability? Again if we get that formula, so here you can see that probability of winning, and that is right-handed divided by probability of right-handed, right? So to form that in that formula, we will get that probability from the cross tab ilog. It will get the 0 for that winnings, right? And similarly for the probability of right-handed. Okay, Now we got that probability nearly 49%. That is the probability of winning given that the player is right-handed. So if we get that the shape of that our D is again nothing but here we have defined that D, this one for. So there are 229 rows and 3 columns. Okay, so get the binomial distribution for a wide range of number of success k. You can consider the total number of record. Actually the actual binomial things start from here. So again it is clearly telling that we need to get the binomial distribution for that wide range of number of successes k, right? So again to get that we importing stats and matplotlib to plot all those graphs. Here we are defining k. So again k is from 0 to 29, which is our range of all these rows, and there is an increment of 1 only, right? We are sorting them on the basis of these values, right? And our n is particularly 229. Okay, so now get the binomial. What we will do is again we will call that probability mass function in that binomial, right? And we are passing k and p as these 3 parameters are required here. So if we plot that figure, so here you can see that we defining the figure size, plotting that binomial, right? And passing the k here, the all the point will be denoted as this symbol. So if we plot it, we are telling that the title should be our this one. Here binomial n is taking from this n and p is taking from p up to 2 decimal points, where n is taken as integer only. So number of successes is x level, number probability of successes is y level. So here you can see that how beautifully the form or the binomial distribution is here, which is equally distributed, right? So here you can see that this is the probability of successes. If we tell that the plot above plot is the probability distribution of number of successes, the winner was right-handed player, right? So this is the number of successes for those winners, and the matches are independent experiment on trial, and the right-handed player winning is our outcome of interest. So let's call it as success. So yeah, thank you. This is all about the binomial distribution. Thanks for being with us.